number I circled, that's about 5.8. And then the one that is right between the 0 and the 1 is about 0.172. So for 87, here are the P's and the Q's. So I'm going to start off by taking the plus or minus 1 from P and putting it over each of the Q factors. So 1 over 1 is 1. 1 over 2 is 1 half. Then I move on to the 3. 3 over 1 is 3. And 3 over 2 is 3 halves. So there are 8 possible rational zeros for this polynomial. And notice the highest number is 3, and I see right here that the graph it passes 8. So I know that I'm going to have irrational numbers, okay, for zeros. So let me erase that. Okay, so it looks like from the graph that it could possibly be, I was trying to see if we could zoom in, but it could be -1 that it crosses through and +1. I'll try and see if those work. So I'll try -1. Oops, change the color. -1. So -2, 17, -25, and -3. So -2, this gives you 2, 19, -19, -22, +22, -3, 3, and it worked. Good. I'm also going to try +1 because it looks like it might cross through +1 or maybe 3 halves. If it's not 1, it could be 3 halves, 1 1/2, right? I'm looking at this part right here. It's kind of blurry, but in your book you could probably have a better view. So it might be 3 halves. So let me try 3 halves. And we could, always change it to 1 and see what happens. So -2, 19, -22, -3. So bring down the -2. 3 halves times -2 is -3. Combine these two, you get 16. 3 halves times 16 is 2 goes into 16, 8, 24. And then you get here 24 minus 22, 2. 3 halves times 2, the 2's cancel and you're left with 3, and so it worked. Cool. So it was -1 and 3 halves. So this is a polynomial, and notice how they're all divisible by 2. So I'm going to go ahead and factor out a -2. So this would be x squared minus 8x minus 1. And again, this obviously does not factor. Okay, so I'm going to have to use a quadratic formula. So let me just set it up. So we have -b plus or minus the square root of b squared minus 4 times 8 times c all over 2a. So I get 8 plus or minus the square root of 64 plus 4, because a negative and then a negative over here, that's positive, all over 2. So that's 8 plus or minus square root of 68 over 2. So 68 is 4 times 17. So the 4 is going to come out as a square root of 2. As 2. And so you get 8 plus or minus 2 radical 17 all over 2. I can factor out a 2 from the numerator. And then reduce this by reducing the 2 over 2, which is 1. So my zeros are -1, 3 halves, and 4 plus or minus radical 17. So I input 4 plus or minus radical 17 on the calculator. So I did 4 minus radical 17, and I got -0.123, and it goes on forever, but I just rounded it to 3 decimal places. And I did the same thing with 4 plus radical 17, and that gave me 8.123. So if you look at the graph, it pretty much that's what it tells us, right? 8.123 is the number, that's where it crosses over here. And then negative 0.123, I covered it up, let me just erase this here. Negative 0.123 would be right here somewhere. So as you can see here, the Q is plus or minus 1, so my P over Q list is going to be basically the P. Plus or minus 1, plus or minus 2, plus or minus 4. And based on the graph, it looks like the 0 is 2, and not 4, 1, 2, 3, not 4, not negative 4, possibly negative 1 over here on this side. Possibly negative 1. So I'm going to start off by 2, using 2 and then negative 1 and see what happens. So 2, oops, change the color. 2, negative 1, 5. I have to use a placeholder for the x squared because there is no x squared, and then negative 4. So negative 1, negative 2, 3, 6, 6, 12, 2, and 4. So there's my 0, and then I'm going to try negative 1. So use the reduced polynomial coefficients. Here, negative 1, 1, 4, negative 4, 2, negative 2, 0. Okay, so it worked. So I'm going to factor out a negative 1 because this is x squared plus 4x minus 2. I'm sorry, plus 2. I'm going to factor out a negative. So that gives me x squared minus 4x minus 2. It does not factor, so I have to use quadratic formula. So we have, I have it set up right there. So minus b would be 4 plus or minus the square root of 16 minus 4 times 1 times negative 2 is plus 8 over 2. So that gives you 4 plus or minus the square root of 24 over 2. This is 4 times 6. So the 4 is going to come out as a 2. So then you have 4 plus or minus 2 radical 6 all over 2. Factor out a 2 from the numerator. And so now I can reduce the 2 over 2. And so the zeros are, I'll put them up a little bit higher. So the zeros are 2, negative 1, and 2 plus or minus radical 6. Okay, so I went ahead and put in 2 plus or minus radical 6 in the calculator, and we got negative 0.449 for the 2 minus radical 6, and we got 4.449 for the 2 plus radical 6. And if you compare these numbers to what the graph says, it's, it confirms what the graph says, right? So let me just point it out. So right here, 4.49, it's about 4.5. So that's about 4.5 right there. And then negative 0.449, it's about negative 1/2. And that would be about here, right there somewhere. Okay, so for problem 107, they're asking you to show that the volume of the package is given by the function v of x, and then what follows. Remember that the formula for a volume of a rectangular prism is the area of the base times the height. So we're going to take, use a different color. I'm going to take this as the base right here, and this as the height. Okay, so it's a square base with dimensions x and x, right? Because it's a square. So it's going to be x squared times y. Now we have to write y in terms of x because the equation is v of x. So volume in terms of x. So we have to find an equivalent for y in terms of x. Now it tells you that the maximum combined length and girth is 120. Now the girth is a perimeter, right? So the girth, and they outlined it with a dotted line around here. So it'd be x, 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 that's the girth. So that means that 4x plus y equals 120. So you solve for y, you subtract 4x, so y equals 120 minus 4x. And that's what I'm going to substitute here. So v of x equals x squared times 120 minus 4x. I can factor out a 4 from here and here, and put 4x squared times 30 minus x, and that's exactly what you see in part A. Okay, for part B, you put this equation into a graphing calculator, and you get something like this. Okay, so I didn't take a picture of the calculator screen, but this is what the graph looks like when you put it in. And then it says use the calculator to find the dimensions of the package that yield a maximum volume. So maximum volume, since the y-axis or the vertical axis is your volume, the maximum volume would be up here, right? So this is about 20, and this up here turns out to be, what was it? This turns out to be 1600, so the vertex of, or the maximum would be at 20 for x, and 16,000 actually for y, or the volume. So when x is 20, the volume is 16,000 cubic inches. So we found the maximum volume, right, of this package. So they actually want the dimensions for this volume. So it would be a 20 inch by 20 inch by, and we need to calculate for y what that would be, right? Remember, y is 120 minus 4x. We had that from before. Y equals 120 minus 4x. So we're going to replace the x with 20, and that gives us 80. So 4 times 20 is 80. 120 minus 80 is 40. So it'd be by 40 inches. So these are the dimensions that give you the maximum volume. For part C, it says find values of x such that v equals 13,500. Well, what I went ahead and I did on the calculator is I drew the line y equals 13,500, and it crossed something like this. And it says which of these values is a physical impossibility in the construction of the package. So we have this, this, and this, and I'll give you those values right now. Okay, so I used the intersect feature on the graphing calculator to find the 3 points of intersection. This one, and this one. Well, the first one gave me an x value that is negative. So that's pretty much impossible, right? Because we're talking about the length of the package. It's not negative. So then this one is out. And so these two are possible right here. So when the package is 15 by 15, and then the other dimension, we can get 13,500 cubic inches for the volume, or when it's 24.27051. So that would be the other one.